Good morning. Morning, year 11s. Hey, Sian, nice to see you. Look at this. Harry and I are in 2. Outstanding. I'll quickly do the register. It's nice to see you guys. How you all doing? Just turning off my other laptop so I don't hear myself back again. It's really interesting, though, hearing the delay. Quickly run ISAMs and do the register. Oh, hey, Marcella. It's good to see you. How's everyone's weekend? Did everyone have a nice weekend? Anch, hello. Minwi, MJ, look at this. Everyone's rocking up. I like it. Hey, Julian, good to see you. Look at that. Doing well. Got Mavella too. So I've got Anch, I've got Harry, I've got Sian, got Mavella, got Julian, got Marcellus, got MJ, got Ira, smashing this out of the bag. Got Michael, got Tom, excellent. Yeah, this is going well. Michael, got Tom, got Meryl. Hi, Meryl, good morning. Oh, my faithful year 11s. Hey, Hibber, good to see you. Doing well. Still waiting on a few. Audrey, has anyone seen Audrey? Isha's in the house. Winner. Getting there. Good morning. Oh. Guys, today I am doing Redox. So I'm going to be teaching Redox. I am going to be giving you guys essentially an A-level lesson. What I will try and then do is give you some example questions from GCSE which really need you to understand it at this level. There is no problem here. I am not going full A-level. I'm not taking it to the end point. Yeah. I'm just going to cover. This is very much going to be kind of a 50-50 mix, and I'll point out the bits that are. But just to let you know, by the way, that I am doing this because it's needed to answer the GCSE Redox questions on your papers. I've never, ever experienced an exam board that gives you a list of topics on a specification and then just blows straight past it. So I'm just going to be teaching you this is going to be a portion of Redox from A-level. And then if people want me to go a little bit further, I can do. But this will be really, really handy. It's actually really good for GCSE for me to be doing this. Okay, so I'm still missing a whole load of people. I'm still missing Elijah. I've got Minwi, don't I? There's a Liz. Yeah, I've got a Liz. I'm missing, there's a Liz, there she is. I'm missing Emmeline. Have I got Russell in the house? No Russell yet. Russell, Catherine, Emmeline, Aisha, Elijah. Anyone seen Elijah? No? Right, I'll mark them all as absent, but I'll keep the register there in case they make an appearance. I think that seems very reasonable. Still missing a whole load. Okie, right. Guys, let's crack on with Redox. Okay, so share screen. There we go. Click on that one, because you don't want to look at my ceiling all the time. Still need to get a hold of another webcam to do that, but then I looked up how much they cost, and I was like, oh, for a decent webcam. I was like, oh, I can't afford that. So that might be a while yet. Okay, right, folks. So we are looking at Redox, which is nice. Cool. Right. Okay, folks. So we have got, today is Redox, and what I will also do at the end of this, I will set a homework at the end of the lesson for you guys to have a go at. Wow, that's big. For you guys to have a go at, I'll set a homework, which again will be a mixture. Oh, that Didney. That's Russell, isn't it? Hey, Russell, good to see you, dude. Quickly do the register for Russell. There he is. Got him. We're in. Okay. And there's Catherine. Oh, there you go. You're in. Still waiting on Emmeline. Okay. So learning objectives today, folks. So the first one is I need you guys to understand the term Redox. Yeah, the term redox. Now you'll notice that I put a dash in there. That dash doesn't actually exist. Yeah, that dash does not actually exist. It is a single continuous word, but I like to separate it every now and again. Yeah, I think you also understand why already. Most of you do. I'm going to put that arrow. Yeah, arrow there. So not really needed. Not really there. Okay. And then we go, so understand the term redox. Then I need you guys to be able to calculate oxidation state. Oxidation state. Now, this is what I mean by Edexcel. Oh, Emmeline's turned up. This is what I meant by Edexcel kind of blatantly just crossing over those boundaries. When you remember when you did your mock exam and there was an exam paper, an exam question on using the periodic table, and the element they gave you was in the F block, which is the one not on the GCSE table, and you were expected to be able to work out its oxidation state. And that's just a blatant crossover into A level by a massive margin. And it was just a great example of how Edexcel was just kind of, well, they should be able to do this anyway, even though it's not specifically on your specification. So we're going to do that today, and it'll be really very, very useful for GCSE because they ask it. So we've got calculate oxidation state, and then I want you guys to be able to complete simple, not complete, don't like it, write simple half equations. That's what we're going to focus on today. Simple half equations. We'll talk about the meaning and the definition of half equations, etc. when we're doing redox. Okay, so I think most people are okay. We can kind of pick up the little bits that we've already been doing from GCSE. So the first thing we can do is we need to give a definition, don't we, of redox. So redox, a chemical reaction. We already know this. I've taught this to you already in lesson. A chemical reaction that has oxidation, and we're going to break these up in a minute. Oxidation and reduction. A chemical reaction that has oxidation and reduction occurring at the same time. I like it. At the same time. Done. So an example of this, immediately, it's worthwhile talking about this. Yeah, just students often struggle with this concept. Yeah, although I think you'll probably find it's okay. So an example of this might be, oh, I keep doing that. My tablet does seem to me, it seems to be more sensitive to my hand than my previous ones. It seems to, every now and again, it'll just open something up. So reduction occurring at the same time. So for example, aluminium solid reacting with iron oxide. Iron, by the way, got to be careful here. Roman numeral would be needed. Iron 3 oxide. Iron 3 oxide to produce aluminium oxide and iron. I wonder whether or not how many students in the room can tell me the name of this very, very, very special reaction. Yeah, the aluminium oxide will come out, technically the iron, that comes out as a solid and that comes out liquid, technically. Although I'm pretty sure the aluminium oxide is actually molten as well at this point. But they just tend to talk about the iron being liquid. Can anyone tell me what the name of this very special reaction is? First person on the chat. Okay, so we can now identify, and this is where we start picking up some rules. So the rules, okay, so let's do rules. Now, what I'm actually going to do, folks, is I'm going to give you guys displacement. Ah, yes, Ira, well done. So this is definitely classed as a displacement. I don't like it being called that, annoyingly. It is a displacement, though. Well done, Catherine. Great job. This has a very specific name, and that's thermite. Well done, Catherine. Great job. There's the answer I wanted. But I'd like to, so this is a displacement reaction, but the problem is we can also class it as a redox. Yeah. By the way, it can also, you're going to hate this. This is the problem with redox. Yeah. There's issues all over the place. This can also be classed as a reduction. Isn't that stupid? But this one requires, this is because this is a reduction because this is metal extraction. You should never call it that. It's really frustrating as a chemist. There are certain bits in here which cause me right issues. I'll come back to this later on. I'll come back to that. So, rules. What we now need to do is we now need to talk about reduction. And by the way, I'm hoping you guys, let's do rules for redox. Rules for redox. Yeah. Red and blue seems very reasonable to me. Yeah. So let's go rules for reduction. Yeah. Rules for reduction. So I think most people will remember from year 9. So what are our rules? I'm going to give you the 2 GCSE rules, and then I'm going to give you the A-level rule, which EdExcel have used on an IGCSE paper. Brilliant. Thank you so much, EdExcel. So, reduction. Number 1, rule number 1. Number 1, loss of oxygen. I think most people will understand that one. That technically is now taught in year 9. I sometimes even, in fact, I actually mention it in my year 7 lessons every now and again. Yeah, it's not always, I don't actually tend to do it deliberately, it just kind of happens every now and again. So we can now see that here's our reduction. And we could tell them why. This is your reduction. Yeah, and it's reduction because the iron oxide, yeah, we can go loss of oxygen, and that is this one, Fe2O3 going to Fe. Yeah, that there is reduction. I should balance the equation, by the way. I really don't like not balancing the equation. It really bugs me. But there you go. So I balanced the equation. Yeah, but we would agree that this reaction, you can't balance this one, by the way, folks, because this isn't a complete equation on its own. Yeah, although we could technically add just oxygen onto the side, and we could do that if you like, but I don't really like doing that. It's not something you can usually do. Yeah, so I'm not going to do that, but we can say that this here is reduction due to iron oxide. Technically, the thing being reduced is him. Yeah, so reduction due to iron oxide, iron 3 oxide. I'll talk about the 3 later. Iron 3 oxide loses oxygen. You could have actually just said iron, they wouldn't care, but that does bother me a little bit. So we pick up our first rule. Now, the next rule for reduction, number two, is we now need to talk about, sorry, I'm going to mute my phone. I've got a million people sending me messages and I don't want any of it whilst I'm teaching. Just going to mute it if I can. There we go. So number 2, and by the way, you guys picked this one up in year 9, yeah? And then in year 10 and 11, you picked up the next one. By the way, this is now also picked up in year 9. We have rearranged the syllabus to make it better, and I now teach this in year 9 as well. It's just better to introduce it earlier because we'll then reinforce it. I'll get it again in year 10 and 11. So we've also got, everyone remembers oil rig. Yeah, oil rig. You get taught this when you cover electrolysis. And there it is, reduction. So we've got number 2, reduction is the gain of electrons. I don't like how long that is. Number 2, gain of electrons. Keep it simple. Keep it simple. Gain of electrons. So what does that mean? I'm going to get rid of oil rig now at that point. It's just a reminder. You know, by the way, I'm still using it there to support myself in remembering that. Gain of electrons. So what does this mean? This means that, I mean, you might get an equation that would say x2 plus will gain 2 electrons and form X. And you would be expected to understand that the electrons being on this side, we know that this side are reactants. Reactants go in, yeah? And these are our products. And products come out. You know this. Well, what you'll notice that in the word gain, there is the word in. And this is how I always remember this. Yeah? If electrons are going in, then you are gaining. What that means is it's reduction. Reduction is the gain of electrons. Electrons in. Yeah? It's a really handy way to do it. Yeah? Okay. So if you see electrons on the left, then it's gaining. We'll come back to this when we do oxidation momentarily. Now, the next one I'm going to introduce you to is an A-level rule. Yeah, this is now A-level. There is one more rule to redox, to oxidation and reduction. There is one more, and that's rule number 3. And rule number 3 is about hydrogen. Yes? So, and it is the opposite. It is the exact opposite of oxygen. If reduction is the loss of oxygen, then it is the gain of hydrogen. Let's do that. So we've got gain of hydrogen. Gain of hydrogen. So, for example, and they have done this to you, year 11, they have. If I take something like, what's the best way for me to do this? The problem is, when they gave it to you with GCSE, they gave you the reverse of this. Yeah, they did the loss of hydrogen and talking about oxidation, not the gain of hydrogen. I'm just going to show you one. So we've got, this is a family that you guys don't know yet. This is an aldehyde. This is F and al. Just to show you this, I don't need to worry about it. You don't need to know it. Yeah, this is an aldehyde. Anyone taking A-level chemistry, you'll pick up your 10 AS families soon. Yeah, if I take ethanol and I add hydrogen to it, I will form ethanol. I will form ethanol. And that there is reduction. Yeah, I am adding hydrogen to this. Yeah, in fact, I can count the number of hydrogens I have added. I have actually added what just the equation actually balances. Yeah, because I've got 4 hydrogens on the ethanol originally. I add another 2, and now we've got the 2 here. Yeah, so that there is reduction, the gain of hydrogen. I know it's tricky. There are 3 rules. Just remember that in reality, these are your 2. These are the most important 2, folks. Hell, you picked up that one in year 7. Yeah, loss and gain of oxygen. Yeah, and then you picked up this one late, kind of year 10/11. For sorry, I'm late. I had Wi-Fi problems. Okay, no problem, Aisha. I'll quickly mark you as in. Has anyone seen Audrey? Anyone seen Audrey? Only one person missing now. So you focus on these 2, and just remember that the hydrogen rule is the opposite of the oxygen. That's the best way I teach this. Latch onto something you already have. That is super useful to be able to do that, folks. Makes things a lot easier. Yeah? latch on this new rule, just latch on to it being the opposite of oxygen. Okay, so now that we've seen red, we now need to see ox. It's only reasonable. Okay, zoom in. So the next one, I need to do this in blue. Oxidation. Oxidation. And the great thing is the rule's just the opposite. I picked up 1 and 2 in year 10. And that's because you only did any work in chemistry in year since when you got me. Oh, that's funny. No, honestly, Ant, that doesn't surprise me. I'm very aware that since arriving at BSKL, I have made an awful lot of changes. Yes, it is right, but I've made an awful lot of changes, and including rewriting years 7, 8, and 9, and 10, and 11, and working to reorganize things to just improve it. So, yes, I do understand that comment. So oxidation, we've now got this, number 1. This is the easiest one. Everyone's got this one, of course. It is the gain of oxygen. We all know this. Yeah, the gain of oxygen. And by the way, just to show Anch the bit that he will have remembered, and you'll probably, Anch, I wonder if I can beat you on this. Magnesium plus oxygen. You remember seeing this when you were in year 7. They take a piece of silver ribbon, yeah, a silver piece of shiny magnesium ribbon. They react it with oxygen. It burns bright white. Yeah, we get this beautiful, bright white flame. Yeah, and white smoke billowing off it. And it is bright white. Yeah, the metal's underneath. And it is super, super bright with light. Yeah, that there is what you'll remember seeing. And that, of course, is oxidation. They may not have talked about the reverse. That wouldn't surprise me. Yeah, but you'll certainly have talked about the idea of oxidation in year 7. Because it's a cool reaction to do, of course. Gaining oxygen, let's balance the equation. There we go. Just to tell you, by the way, this reaction is heavy GCSE. Yeah, GCSE. This is a very, very important reaction that you guys need to know. Yeah, you need to know that when magnesium or calcium or sodium, any of those reactive metals burn, yeah, but this one's very specific, bright white light, bright white light, and white smoke. You need those 2 observations for this. Yeah, just to tell you what the white smoke is. The white smoke, of course, is the magnesium oxide being made. Yeah, you make this white smoke coming off it because the magnesium oxide is ionic and is a solid, so you see white smoke. Yeah, of MgO, magnesium oxide powder, being produced. Yeah. Magnesium is amazing, by the way, because it burns at such a high temperature. That reaction is insanely exothermic. Yeah, nice to remind ourselves of our symbols. Yeah, minus delta H. This is just a nota bene. Yeah, that minus delta H is the symbol for exothermic. Yeah, and this reaction is so exothermic, it reaches temperatures in excess of, give or take, about 2,600 degrees C on burning. And it burns so hot, you can't put it out with anything. Can't put it out with carbon dioxide. Can't put it out with water. It's insane. It explodes on contact with water. It's really cool. It's a great demo. I do this one in class. So I'll do it now for you guys if you were in school. And if you ask Catherine and Harry, they were practicing this one for me for my show. Putting out a magnesium fire with water. Amazing. Very, very cool demo. So the next one, rule number 2 is electrons. Yeah, and we remember oil rig. Yeah, oil rig. Oxidation is the loss of electrons. Yeah, it's the loss of electrons. Seems reasonable. Let's look at an example of this. Let's look at the example. I'm glad you remember, Harry. It's cool, isn't it? It was an amazing demo. Massive, bright sparks and shower of sparks everywhere. Amazing, great demo. Loss of electrons. So the example here would be that magnesium metal is becoming magnesium 2+. Yeah, you've got to balance it. The 2 electrons are on this side. So the electrons are coming out. Yeah, what that means is that this is oxidation because reduction is the gain of electrons. Gain has in it, loss doesn't. Yeah, this is loss of electrons. Out is loss. Yeah. Okay. So let's continue with that. So if we've now picked up this, by the way, we're going to talk about half equations later. Number 3, this is the A-level bit, of course. This is all hydrogen now. So gain, so the opposite of oxygen. So we've said that oxidation is the gain of oxygen. So therefore, it's the opposite, loss of hydrogen. And this is the one that came up. Yeah, this is the one that came up at GCSE. Very frustrating. I just don't really think it's very fair when they do this. Yeah, I'm tempted to see if I can give you the equation for it. Problem is, you see, I just feel like it's all a little bit. There are problems with it all over the place. I'll come back to that equation later. I'll hopefully find. I think it was on the last exam paper we reviewed, so I'll go back to that and see if I can track it down. Okay, so guys, now that we've picked up all of the rules, now guys, we have taken this now, thanks to the gain and loss of hydrogen, we have taken this up to A-level standard for being able to recognize when this happens. Yeah. Trying to think of a really good example. If I do the reverse of what we did before, just trying to think of another one. Could I do another one? Trying to think of one. Another really good example of loss of hydrogen. Don't know. Can't think of one off the top of my head. Anyway, I was going to reverse the ethanol to ethanol, but I just thought that was a bit of a cheat. Okay. Oh, problem is removal. Okay, I'm just showing you some more organics, folks. I may as well. Yeah, more organics. This is A-level organic. This is not it's AS level organic, so first year of A-level. So you'll pick up all of these families when you start in a couple of weeks. Quite excited about. So this here is called ethanamine. Ethanamine. By the way, this is the new name. It's rather upsetting for me, this. I'll explain that another time. But this family here is an amine group. Yeah, that there is this bit. Yeah, that's there, an amine. And of course, you can see the rest of it and how you can see the parts from year 11 that come through. Yeah, we've got eth, 2 carbons. There's the eth. And then we have the an, which is single bond. Yeah, there we go, ethan. And if I had an H, it's ethane, but then with the family, you get ethanamine. Well, I could actually remove the H's from this, and I could form this. And this is another AS family. Yeah, I just removed the H's. Yeah, and this is ethane. This is rather interesting. The E comes back because the end family, that family there, is a nitrile. Yeah, so I'll highlight that bit. That bit there is the family nitrile. Notice, though, really interesting this one because I shouldn't, that's just too thick, it's just irritating me. Yeah, that one there is still ethane because it's still eth because the 2 carbons are there. It is still an ane because it is still a single bond. Yeah, all the names are built in this process, makes everything so much easier. But what you'll notice is this is loss of hydrogen. Yes? What that means is I can immediately go, oh, hang on a minute. So the loss of oxygen is reduction. Yeah, so oxidation is the gain of oxygen, reduction is the loss of oxygen, hydrogen is the opposite. So if the loss of oxygen is reduction, the loss of hydrogen is oxidation. Yeah, loss of hydrogen. So this is going to be brackets oxidation. Yeah, and they've done this to you folks. It's a nightmare. Edexcel or GCSE, very frustrating at times for me as a GCSE chemistry teacher because I realize that I need to be trying to incorporate a bit more A-level into my lessons more and more, and I do enough of it as it is, to be fair. Okay, So what we can now do is we can all box off that one there. We can box off that. Now what we need to do is calculate oxidation state. Okay, so first thing we need to do here, folks. First thing that we need to do here is we now need to go oxidation state. So the first thing is, what does oxidation state mean? Yeah, oxidation state is the posh word for charge. Yeah, posh word for charge. That's it. I'm actually going to write that down for those people, I don't know, who would listen to this without the sound. I don't know. Posh word for charge. Yeah. So now most people would say, oh, well, charge is easy, because if I see Al3 plus, that there, the oxidation state is given for me. That there is the oxy state. Yeah. For those other students who do the research and do the extra reading and stuff, you might also come across the word valence. Yeah, valence shell. Valence means outermost. But sometimes I often see odd questions where they say things like valence charge, which I really don't like. But the word valence simply means outermost. Yeah, but just thought I'd throw that in there. But oxy state is +3, so this is easy. But everyone here realizes that most of the time the oxy state isn't shown. So let's go for this one, Al2O3. I'm sticking with aluminium because there's some nice reasoning for me to be able to do this. So we all know that the first thing that we can always do is we can turn to my wonderful, beautiful table. Yeah, this table is the best thing that ever happened to science. God, there are going to be people who are going to hate me for saying that. But anyway, the periodic table is awesome. But what we know is that the columns, these groups here, notice I skipped the transition metals. Yeah, these groups, yeah, we can assign, and then these are the TMs, and these don't get a charge because they have multiple. But group 1 is +1, group 1 is +1, group 2 is +2, group 3, I'm just going to erase all these, group 3 is +3, group 4 is +4 or -4, and this is the point where it switches over. Yeah, now we get -3, -2, -1, and no charge for the noble gases. Yeah, so this is really handy because now we can find aluminium, and we can go, oh, aluminium is in a +3 charge. Yeah, we can say, oh, aluminium here, thanks to our P table, is we can say it's going to have a +3. Aluminium's +3 according to the table. But the great thing is we can check this. Yeah, we can check this. The reason being is that after aluminium's +3, we know that they're in this compound. Let's zoom in on this. Yeah, let's zoom in. So in this compound, I have got 2 aluminiums. And what would that look like? That would look something like this. Aluminium 3+ and aluminium 3+. Well, if they're +3, I've also got 3 oxygens in here, but they're not oxygens anymore, they're oxides. And they are, where do I find that on my table? Oxygens over here, it's a 2-. So we've got O2-, O2-, and O2-. Please note that there, I hate that, I'm going to change that. No, there should be no overlap because this is ionic. Yeah, there we go. And that makes total sense now, because what you realize is that the aluminiums, I have 2 aluminiums here, trying to do this to make it easy. I've got 2 aluminium 3+ in this compound. The total positive charge that they're bringing is +6. And I have 3 O2-. And the total overall charge that they're bringing is -6. This makes total sense because at this point, they cancel out to give me no overall charge. So everyone's going, okay, that makes sense. So how can we now use this to work out other people who we might not know? Okay, let's have a look. So we now realize that we can actually dismantle compounds. Let's look at this guy. Let's start simple and then steadily get harder. So question number 1, FeO. I'm now going to tell you that I want the charge on the ion. That's the question. Right, guys, on the chat, please. You can pause the video. Can you please tell me on the chat, as soon as you've got it, what is the charge on Fe in this compound. So you can pause the video and then I'll run through it. Okay, so what we now do is, if this here, we are flagging this in the question as the unknown. Now, if we have flagged someone as unknown, well done, Harry, well done, Hibbert, well done, Anch, well done, great job, really proud. So if this one here we are deciding is unknown, what that means is everybody else is what's called standard oxystates. So what that means is the standard oxidation state is found on the table, on P table. So I now go, oh, okay. So I can now say that oxygen is O2 minus. Great job, Liz, well done. Is O2 minus. How many of them do I have? I have only got one. So I'm going to times that by 1. Total charge here is -2. Next, right, how many ions do I have? I have got iron and I have got times 1. So what that means is the charge must cancel out the 2 minus, which means iron must be in a +2. So I think most people are going, okay, kind of makes sense. Yeah, I've got loads of people on the chat who are already there. 5 people are like, easy, already do it. Brilliant. Let's make this slightly harder, shall we? Okay. Since that was so easy, let's up it. Okay, question number 2. So let's go for K2Cr2O7. What is the charge on chromium in potassium dichromate? Now, year 11, you know that you need to know this guy. You don't need to know its formula, just the name. Potassium dichromate is one of my favorite substances because it is highlighter orange. It's beautiful stuff. Incredibly toxic, like lethal, totally lethal, but beautiful. And we use this. This is one of the tests for alcohols. Yeah, if you add that to an alcohol, you need a little bit of sulfuric acid as well. Add to alcohol plus dill H2SO4, it will turn green. We know this. The test for an alcohol, yeah, turns green. It'll turn green. If you're interested, that's chromium 3+. That's actually causing the green color, just so you know. So, has anybody on the chat given me an answer yet? What is the charge on the chromium? What that means is I am telling you that the chromium is unknown. Everyone else must be standard. Yeah, standard from table. Standard. Yep, still nobody on the chat yet. So chromium is the unknown. Everyone, so potassium, find it on my table. +1. So I have got K plus times by 2. Total charge from him is +2. Yeah, I'll do 2+. Why not? Whichever way round makes no difference which way round you go, by the way. They don't care. Right, here's the unknown. Well, what do I now have for oxygen? Well, oxygen is O2 minus because my table says so. Anch, you hero, well done. Oxygen -2. Well done, Anch, great job. So we've got 2 minus, but there are 7 of them there, times 7. So that's going to give me -14. Right, and I need to get to 0. What that now means is, if I take +2, let's move it down so we're on the same line, +2 and -14, I get an answer of -12. I'm actually going to flip the sign over that case. What that means is, for this to get to 0, I need to add 12. The chromium must be bringing +12, but there is 2 of them in it. Divide it by 2, and I get +6. Well done, Ange, the only person who posted an answer on the chat and it was correct. Ange, outstanding. This is A-level chemistry at this point. Yeah, well done. Really proud of you, dude. That's outstanding. Next, I'm just suddenly realizing I'm not really watching the clock. Oh, okay. Sorry, need to check my lessons. Have a look. 9:25. Okay, still 15 minutes. This is good. Right. Well done, Ange. So proud of you. Great job. Right. Now, did everybody follow this? I hope you did, because I'm going to give you another one. Question number 3. Question number 3. H nitric acid, HNO3. What is the charge on the nitrogen? On the chat, please, as soon as you can. So all we're doing, folks, is determining the charge of an atom within a compound. That's what we're working at here. This is called oxidation state. Yep, that's what this is called. Oxidation state. Oh, look at that. Heather's in with an answer. Well done, Heather. Great job. It's nice to see progress being made in a lesson. That's outstanding. Well done, Morella. Great job. Right, let's break it up. If we're asking for the nitrogen, everybody else is standard. Hydrogen, we all know from acids and bases, H is H plus. Next, oxygen is O2 minus. We get used to this, folks. And there are 3 of them. So we've got +1 from hydrogen, -6 from oxygen. I need a charge of 0. There's no overall charge. So the nitrogen must be bringing +5. Outstanding. Well done, Heather. Well done, Morella. And there's only 1 nitrogen in it, so this is correct. Winner. Great job. Good job, girls. Well done. So what we're doing here is just working out the charge within a compound. It seems very reasonable. It's a very straightforward process. Are we ready for the next question, folks? Let's go for the next one. Just slowly working our way through them. Let's go for the next one. Let's go for, this was, I realized I just deleted the number. That was question 3. This is question number 4. Question 4. Okay, I'm now going to make it a little bit more challenging. I'm going to add a charge. Yeah, this is adding an extra step in the process. So let's do SO4 2 minus. What is the charge on sulfur? Now, this is now stepped out of GCSE entirely and into A level at this point. Don't overthink it. Run the same process, but remember you need to adjust for the charge. Yet this molecule has an overall charge of -2. And that's what we've got to get to. What is the charge on sulfur, please, year 11s? See who's the first person to put on the chat. You can pause the video and have a go at it. Right. So sulfur is our unknown. What that means is everybody else is in standard. So we've got an unknown. What that means is that everybody else is in standard. Heather's gone for +3. Interesting. It's not +3, Heather. Incorrect. Have another go. So we've got O2 minus. This must be in standard. Yeah, standard oxy state from the table. So O2 minus, Emmeline says +3 is, wait, no, it's definitely not +3. So you've got O2 minus and it's times by 4. Yeah, total number -8 in total. And I need to get, with sulfur, whatever charge sulfur brings, it needs to bring the final charge to -2. It's not +8 either. If it was +8, if S was +8 here, folks, this was +8, then the SO4 would have no charge at all. It would be that. But it's not. It's SO4 2 minus. Hey, Morello and Merrill are in there. And Emmeline's in there too. Well done. Yeah, that's because S is bringing a +6 and the O's are bringing -8 to give me an overall charge of -2. I know that's tricky, folks. It adds an extra level of complexity to it. Well done, Merrill. Well done, Ant. Good job. Yeah, are you ready for your next one? You ready? Let's keep going. Question 5. All I'm doing here, folks, is just continuously making this a bit more tricky. Yeah, if you want me to back it off, no problem. Okay, I get it, I think. Good job, Ant. Let's go for NO3 minus. What is the charge on nitrogen? What is the charge on nitrogen? Okay, so we have got oxygen must be standard, O2 minus from my P table. Yeah, my periodic table tells me this. Yeah, Hibber's in there, Morella's in there. Look at this. They're getting good, aren't they? Getting quicker. Look at that. It's great to see how people in pace increases. Anch, try again. So we've got there O2 minus times 3, total charge -6. I need to get to an overall charge of 1 minus. Nitrogen must be bringing +5 to cancel it. Yeah, I should stick with one or the other, Mr. Duncan. N + 5, and we're done. Yeah, there we go. I like it. Great job, Ants. That's correct. So now, by the way, I've seen all kinds of clever things, the way that people do this mathematically. Yeah. There are various ways that you'll be able to find. This is just the way that I run it, and this is the way that I see as the quickest method of doing this. Yeah. But there are others. You can do this like algebraically and all kinds of fun things like that, but I don't want you to overthink it too much. So this is the method that I teach. Okay, are you ready for the next one, folks? Question number 6. Okay, question number 6. Let's go for I'm tempted to give you the one that was in the that was on the GCSE exam. Ah, isn't that clever? I can't use that table now because it wasn't on the one that they got. They got neodymium. That was such a pain. NDF3. Whoops, sorry. NDF3. What is the charge on neodymium, please? Off you go. Pause the video. Have a go. What is the charge on neodymium? Dymium. What is the charge on neodymium? So we now have everybody else is in standard. F1 minus. Yeah. So we've got F. Just going to put 1 minus there. I'll actually put F1 minus. It's nice to do that. Or F minus 1. Yeah. And then we've got 3 of them. Total -3. Right. There is no overall charge, which means neodymium must be +3. We're done. Great job. Thanks, Harry. Well done. Thanks, Hibber. Thanks, Harry. Smashed it out of the park. Well done. Great job. Yeah. What they then did was, this is why at GCSE, they really did this was hard. Like, there are some teachers who've never taught this concept of oxidation state before. Yeah. And then you had to do that in a GCSE exam and then predict what the formula would be if you reacted neodymium with oxygen. And they didn't tell you to look at this. It was hard, man, because you worked out that neodymium was a +3, therefore it's going to be it's going to be ND3+ and O2 minus, cross and down, ND2O3. There we go. That was so hard. That was GCSE paper 1, I believe. No, maybe not. Maybe it was paper 2. Must have been paper 2. Must have been, because that's crazy hard. And that was done at GCSE. Madness. Anyway, right. Are you ready for one more? You ready for the hardest one yet? People never like this as they get harder. They're like, oh, I am game goes. Okay, question number 7. I'll do again. I'll make it relatively medium. Let's choose someone from the table that you wouldn't know. Let's just, for fun and games, let's go for. Ooh, gotta be careful here choosing people down here. It's horrible. Let's go for europium. Yeah. So I don't even know. It's simple as EU. Of course it is. EU brackets OH4. What is the charge on europium? Off you go. Let's see if you guys can do this quickly, or it takes you a while to do it. I don't need to, by the way, it's going to be very interesting to see how you tackle this. There are 2 methods. Look at that. Well done, Harry. Straight out of the box. Outstanding, young man. Really impressed. Well done. Commendation for you. Well done. Outstanding. So we've got Harry's done this. We've got OH minus, and there are 4 of them. Total is -4. There's no overall charge. Europium must be +4. I am done. Harry, superb. Good job. Well done. Yeah. By the way, do you want to see the long way? Do you want to see the long route just for fun? Just for fun. EU brackets OH4. Right, look at this. So if I'm looking for him, everyone else is standard. I've got 4 H's. H's are H plus times by 4 gives me +4. Next, I've got 4 oxygens. Oxygens are O2 minus times by 4. That's going to be -8 in total. Right. So if I already combine these 2 together, already combine these 2, then I'm going to get -4. And then europium must be cancelling it out with no overall charges +4. Lol, cats. Bit of a long way around. You'd never do it, by the way, folks. You never ever do this. Yet you always treat the complex ions as entities themselves. The reason being is in the complex ions, except for OH minus, they're all in funny charge states anyway. Tending to give you some more of those as well. Right. So can I just point out? Let's go back to the end of the lesson. Dawns is nigh. So what we can now do, folks, is we can definitely define redox, and we can definitely calculate oxidation state at an A-level level at this point. Well done, folks. Right, I'm going to end the lesson there with only 2 minutes to go, and I'm not. There we go. Go back to here. There we go, folks. Right, I will leave you guys be. Next lesson, we'll continue this, and we'll do creating simple half equations. And maybe even do a little bit of complex half equations as well, Samela. Guys, I will leave you be. Have a great rest of your day. It's been a pleasure to see you guys as always. I miss you loads. Take care.